Hello everybody, this is lesson 1 of lecture International Economics. I will discuss slide 1 to 47. Before we start, let me give you an overview of the content of this lecture. I begin with a short review of the very old history of trade. As we will see, trade is not a modern phenomenon, but has been practiced since the beginning of human history. In section 1.2, we will then explore two different reasons why trade can be profitable. Trade caused by comparative advantage and trade caused by economies of scale. We will also see that a transition from autarky to free trade causes winners and losers. If there are no market imperfections, it is possible to show that winners win more than losers lose, such that total welfare typically increases. However, the market mechanism does not compensate the losers. Consequently, a normative policy question can arise. We will discuss various proposals how to deal with this problem. In section 1.3, I will give an overview about the instruments and targets of trade policy. We will first discuss the standard instruments of trade policy, tariffs, and quantitative restrictions. Next, we will overview in section 1.3.2 a couple of the major trade policy doctrines which are in the discussion, such as the classical free trade doctrine, the import substitution policy doctrine, the export-oriented industrialization doctrine, and finally the globalization critique. Finally, in section 1.3.3, we will take a closer look how the World Trade Organization works. If we look back in the history of trade, we find that long-distance trade is not a modern invention. The first traces of long-distance trade reach back to the time shortly after the appearance of Homo sapiens. Such traces are seashells found far away from coasts, or flintstone or obsidian tools far away from regions with natural deposits. The first representatives of modern Homo sapiens appeared around 170,000 years ago. This diagram has been developed by the prehistorian Stephen Oppenheimer. This line of technical cultural innovation increases every time an important technical or cultural innovation had been made by Homo sapiens. If you take a closer look at this line, we find that shortly after the appearance of Homo sapiens, long-distance exchange had been invented, a major cultural innovation. Long-distance trade preceded other innovations like barbed hooks, bone tools, fishing, shell fishing, cave paintings, and the like. So why did Homo sapiens invent trade? According to current paleoanthropological research, traces of long-distance trade are found only in relation to Homo sapiens. Other hominids, even the highly developed Neanderthals, have not practiced long-distance trade, as it seems. An explanation for this could perhaps be found in another peculiarity of Homo sapiens, namely gender and age-specific division of labor within small groups, hordes and families. The prehistorians Stephen Kuhn and Mary Steiner presented empirical evidence that typically men in those times engaged in hunting large animals, while women and children engaged in collecting vegetables and small animals. At the end of the day, the different groups came together, shared their prey and prepared their food. So this is already a kind of inner group trade exchange. It is interesting that a similar division of labor can still be found in currently existing Stone Age cultures like the Hadza or the San in Africa. Why is this type of division of labor advantageous? The economic answer to this question is by specializing in different ways of food production, total productivity grows. Those who went hunting had the possibility to develop special hunting weapons and special skills for hunting large animals. Those that went collecting herbs and vegetables developed special tools for this and also accumulated the knowledge for finding these type of edible plants. Thus, division of labor and exchange of the different goods of production increases total food supply. A higher food supply, however, increases the probability of survival and to create offspring. Some paleoanthropologists hold this as one of the reasons why among all representatives of the tribe Hominini only Homo sapiens survived until today. Consequently, it is possible that trade and division of labor played an important role in the history of Homo sapiens. It is possible to give an example, a numerical example, how specialization and trade can increase total productivity. I would like to show this based on an example that goes back to the economist David Ricardo, who lived in the 19th century. He has, for the first time, presented this example in his book Principles of Political Economy and Taxation. David Ricardo based his example on the trade of wine and textiles between Portugal and the United Kingdom in his time. It is, however, possible to adapt this example to the case of two persons that engage in mutual trade. So let's assume we have two let's say, Stone Age persons, Fred and Barney, and let's assume that they can produce two types of goods: Flintstone blades or fur coats. Let's assume that Fred needs 3 hours for the production of one Flintstone blade. And let's assume that Barney needs only 2 hours for the production of one Flintstone blade. Now, in the production of fur coats, Fred needs also more time than Barney. Fred needs 6 hours for one fur coat, while Barney needs only 1 hour for the production of one fur coat. Now, if both produce independently from each other, which means without division of labor and without trade, one Flintstone blade and one fur coat, then Fred would need 3 hours plus 6 hours equal to 9 hours time, while Barney needs only 2 hours plus 1 hour equal to 3 hours time. So this is the result if they produce independently from each other. It is important to note that Fred has a lower productivity in the production of both type of goods compared to Barney. He needs more time to produce a Flintstone blade, and Fred needs more time to produce a fur coat. So the question is it possible that under such circumstances mutual beneficial trade takes place? Does it make sense for Barney to engage in trade with Fred even though Fred has a lower productivity in the production of all type of goods? So let's see whether under these extreme assumptions mutual beneficial trade is possible. Let's make a kind of experiment. Let's assume that Fred specializes in the production of Flintstone blades, while Barney specializes in the production of fur coats, and that both exchange Flintstone blades and fur coats at a barter rate of 1-to-1. What is the result, or what would be the result of such a trade deal? Well, if Fred uses his time to produce 2 Flintstone blades, one for himself and one for Barney, he needs 6 hours time. 2 times 3 hours. If Barney produces 2 fur coats, one for himself and one for Fred, he needs 2 hours time. 2 fur coats times 1 hour is 2 hours time. Now, they exchange 1 Flintstone blade against 1 fur coat. So, as a result of this deal, both end up with the same amount of goods as before. Everybody possesses now 1 Flintstone blade and 1 fur coat. However, if we compare their production hours, we observe that Fred has now only 6 hours to work instead of 9, while Barney has only 2 hours to work instead of 3. So both gain time. Fred gains 3 hours, Barney gains 1 hour. In this sense, trade is for both advantageous. So it's a win-win game. Both gain from this type of mutual cooperation. Why is this type of mutual beneficial trade possible? Well, a closer look at the numbers shows that Fred opportunity costs in the production of Flintstone blades is lower than Barney's, even though his absolute costs measured by working hours is higher. What does this mean? Well, let's have a look at the lowest row of this table here, where the costs of a Flintstone blade is measured in terms of the production of fur coats for gun. If Fred produces one Flintstone blade, he needs 3 hours. So he has to give up half a fur coat, because for a fur coat he needs 6 hours. Now if Barney produces a Flintstone blade, he needs 2 hours. So he has to give up the production of 2 fur coats, because for a fur coat Barney needs only 1 hour. So from this perspective, Fred's opportunity costs, his relative costs in the production of Flintstone blades, are much lower than the opportunity costs or relative costs of Barney in the production of Flintstone blades. Therefore, both can gain from mutual trade if Fred produces in the product where his opportunity costs are lower than Barney's opportunity costs, and if Barney specializes in the production of the product where his opportunity costs are lower than the opportunity costs of Fred. This is the mathematical mechanism behind this numerical example. It is possible to prove mathematically that mutual beneficial trade is always possible if, in this way, the opportunity costs of the trade partners differ. After the idea of division of labor by exchange within small groups was invented by early Homo sapiens, it was only a small step to apply this idea to trade between different groups. This should not only have caused additional productivity gains by deepening inter-group specialization, but also made Homo sapiens more peaceful. Individuals or groups of individuals who trade with each other become dependent on each other. So this increases the opportunity costs of martial conflicts between these groups. Martial conflicts, very often in combination with cannibalism, is often observed between other hominids, for example within chimpanzee populations. Higher productivity combined with more cooperation within and between groups could indeed therefore be one reason why our species, Homo sapiens, has crowded out other hominids like the Neanderthals. This table displays examples for wide area trade systems in ancient human history. About 6,000 years before the current era, a kind of Stone Age European Union existed in our part of the world. Prehistorians have established the existence of a network of trade routes along the rivers traveled by log boats. Lakes like the Lake constants acted as crossroads in these networks. The famous Stilthaus village in Unteruhlingen in the Lake Constance has most likely been constructed to ease the charge and discharge of these logboats. So, in a sense, it represents a kind of early Venice. Uruk, one of the oldest cities in human history, practiced trade with its hinterland primarily. The residents of Uruk organized an artificial irrigation system and thus specialized in the production of agricultural goods. These were exchanged with hunter-gatherer cultures in its hinterland, mainly for products like furs, jerky, and wood. In the Indus Valley, a wide area trade network was established based on sailing boats and ox carts. In ancient Egypt, the Nile was used as a tradeway, and so on, as the other examples show. Of special importance for Europe was the development of the Phoenician trade network in the Mediterranean. The Phoenicians invented a sailing vessel with a keel. The keel made it possible to sail upwind. The Phoenicians founded barter towns like Tyros, Sidon, and the Spanish city of Cadiz. In Cadiz, they traded all kinds of Mediterranean goods against silver from the mines of Tartan in Spain. In the tradition of the Phoenicians, Greek traders founded also barter towns around the coast of the Mediterranean Sea. One of these barter towns was Marseille, founded around the year 600 before the current era. Marseille became the most important trade center of ancient Europe. The Greek used the largest bay of the Kalong as a kind of natural harbor. They built harbor facilities for their standardized sailing vessels. Remains of these harbor facilities have been preserved and can be visited in Marseille today. Marseille became one of the most important European trade centers. The traces of old trade routes discovered by archaeologists show the importance of Marseille as an economic hub of its time. Archaeologists found that the most important trade commodities had been wine, pottery, colorants, medical and spicy herbs, corals and cork. One important trade relation existed even with South England. The tin mines delivered one of the resources necessary to produce the most important metal of the era, bronze. These are the remainings of a typical Greek sailing vessel found in Marseille. The Greek sailing vessels resembled a lot the Phoenician sailing vessels, the Biremic galley. To sum up, the history of our species shows that trade has always been an important cultural technique. We've already analyzed why trade between individuals with different opportunity costs in the production of goods, like Fred and Barney, can be mutually beneficial. In the next sections, we will transfer this simplified numerical example to the more general case of trade between two countries. As we will see, to examine the welfare effects of international trade on a market the distinction between consumer surplus, producer surplus, and cooperation surplus is useful. In the following, these terms are graphically explained. The theoretical backbone of this exercise is the so-called welfare analysis, which is, I think, well known from microeconomics. Let's start the repetition of welfare analysis with a standard market diagram. In welfare analysis, we use the areas below the demand and the supply curve to measure consumer and producer welfare. To see how this works, let's change the shape of these curves to staircases, like this. This is a demand curve for a good that is not divisible, well, such as cars, refrigerators or TV sets. Let's say we talk about the demand for refrigerators in the following. So we can trade only whole quantities. We can only trade 1 or 2 or 3 refrigerators, not 1.5 refrigerator. The equal 1 unit size of every step is chosen for simplicity here. It could as well be larger than 1 unit. Given this shape of the demand curve, there must be one consumer willing to pay as much as 17 euro for one refrigerator. So the willingness to pay for the first unit of this good must be 17. There must also be one additional consumer willing to pay 17 euro for another refrigerator. So the willingness to pay for the first and the second refrigerator must be 17 plus 16 equal to 33 euro. And so on. The maximal willingness to pay for 3 refrigerators equals then 17 plus 16 plus 15 equal to 48 euro. Given this logic behind the demand curve, what represents the sum of all green columns in this diagram? Well, it represents the maximum willingness to pay for 17 refrigerators, and it equals 153 euro. If you now add the supply curve, it is possible to determine the market equilibrium price. To remember, the market equilibrium price is the price where supplied quantity is as large as the demanded quantity. This is given here at a price equal to 10 euro. At this price, demand and supply equal 8 refrigerators. If you add up the willingness to pay for the first 8 refrigerators, we find that it equals 17 plus 16 plus 15 plus 14 plus 13 plus 12 plus 11 plus 10 equal to 108 euro. So this is the maximum willingness to pay for 8 refrigerators. It is equal to 108 euro. However, given the equilibrium price of 10 euro, every consumer has to pay not his maximum willingness to pay, but only 10 euro. As a result, total payment by consumers equals only 8 times 10. 8 refrigerators times 10 euro equal to 80 euros. This amount is equal to the surface of this red rectangular. If you subtract now these 80 euros from the maximum willingness to pay for 8 refrigerators, we receive an excess willingness to pay of 28 euro. Graphically, this amount of money is equal to the green staircase, the little green staircase here above the red rectangular. What represents this area now? How can we interpret this little green staircase here? Well, it is the sum of the excess willingness to pay above the market price. So it measures in money terms how much more the consumers appreciate these 8 refrigerators than they have to pay for them. It is therefore called consumer surplus or net consumer welfare. Now, is there also a similar thing for producers? Something like producer welfare? Well, I think it is clear that the total expenditures of consumers equal to 80 euro equal the sales success of the producers. The question is therefore, what are the producers' production costs for these 8 refrigerators? To find the production costs, we have to look at the supply curve, which represents the marginal costs of production. Consequently, it tells us that for the first refrigerator, production costs equal 3 euro. For the second refrigerator, production costs equal 4 euro. For the third fridge, production costs equal 5 euro, and so on. What represents then the sum of all these blue columns for 8 refrigerators? Well, it represents the variable costs of the production of 8 refrigerators. These costs equal 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 euro, which is an amount equal to 52 euro. If you subtract now this amount of production costs from the sales success of 80 euro, we receive an amount of 28 euro, which represents producer surplus or producer welfare. As a result, we have now this yellow area which measures consumer surplus, and we have this red area which measures producer surplus. Consumer surplus, producer surplus. For simplicity, we assume in the following, again, perfect divisibility of goods, such that we have straight lines instead of these steps or staircases. Of course, under this assumption, the interpretation of the yellow triangle as consumer surplus and the red triangle as producer surplus stays the same. Okay, we will call consumer surplus plus producer surplus the following total return of cooperation, or simply total surplus. In a market equilibrium with complete competition and absence of external costs or other disturbances, total surplus is always maximal. An increase of production above the market equilibrium quantity, QE, causes an increase of production costs above the willingness to pay of consumers, therefore total surplus falls. To the other hand, a reduction of production below the market equilibrium quantity QE causes the willingness to pay to be higher than the production costs. As a result, total surplus would fall again. So much for the first lesson of the lecture International Economics. In the next lesson, we will apply this welfare analysis to analyze the consequences of international trade on the welfare of consumers and producers.